Hello, welcome back to Sushi Live Noding. In this episode, we're gonna revisit the Pixel to ASCII conversion once again, and I will be using Sverchok add-on and Animation Nodes add-on to perform this conversion. So you can see here, I have the original image, this strange mask that I did, and I somehow managed to convert it into this kind of ASCII art. It is actually 3D as well, and I'm using I'm using animation nodes to do this part. If you look at it from the top view and orthographic, so you can see this is like just like a normal ASCII kind of art, but of course this is like 3D. And so let's see how I did this. I am going to give you the blend file with all this node tree setup, but I started like this inside Sverchok. So I start with this image decompose. If I'm not wrong, there's some kind of limitation on image decompose. Maybe 1,000 by 1,000 pixel will be too big. It's gonna be like 1 million pixels, and I don't know, maybe this thing can handle more, but it depends on your computer memory as well. It's gonna be, if it's too big, then it's gonna perform very slowly. So this image is 214 by 260 pixels, and of course pixel is that square we are looking at. And with image decompose, we can actually skip some pixels. So I'm skipping some pixels, and that's why I'm getting this kind of like a more like low res result. Sometimes that's actually that's what's needed. You don't need the whole pixels to do it. So this image decompose will extract the XY position and also the RGB and also the polygon. By default, it will actually generate something like this. So it's not exactly like 1 pixel and 1 polygon phase, but it is actually more looking at the vertices. So this is the setup for it. Image decompose and viewer vmesh, just output it, and the color comes from this RGB, goes into the vertex color. That's why we specify. Even though it's cool, but we want it more. Sometimes we want it more on the pixel. And what I did here, for every vertices, I am generating a circle. And where's the circle? This guy. So for every vertices, there are like 1,178 points. We are generating circle, and for every circle, we are coloring it with a color from this image. As a result, we're gonna get this. Currently, the circle is actually a triangle, so I can increase this to 8, and should turn it into a circle if this is still working. Let me try updating it and make it 12. Update it. It's not updating. Let's try to reload it. There you go. That's the result with the circle, and the circle is probably too big now. So 0.04. So this is a slightly better representation of this image. Even though it's not like perfectly on the polygon center, it's not like perfectly on the circle. It's more like on the points there. But that's okay. That's kind of like an easy way to do it. You can of course make a different setup where it is actually kind of pixel by pixel sampling. So anyhow, we get this, and from here I actually kind of output another setup that I'm gonna pass the data into animation nodes. So based on this information, instead of just passing the color and then instancing the circle, what I did here is I'm actually separating the Z value. So if you look at it, okay, there's a length here. I'm measuring the length of every color, RGB color. So we're gonna get like some kind of grayscale, and based on that grayscale, I'm remapping it. I'm remapping it value 0 to 1 to value between 1 and 9. And this value is going to be important because imagine for each sampling of the pixel here, approximately we're gonna have some kind of grayscale value, right? Between 0 and 1. 0 is black, 1 is white. And we're gonna get some value in between, like grayscale. And I'm using round as well here, and I'm outputting it as some kind of polygon edge, like a displacement, or in this case it's more like points. If we get rid of if we turn off only render, we should actually see there is a bunch of points somewhere. I call it yo. Where is it? Outliner and check. So yo is currently hidden. I'll turn it on. So yo actually looks something like this, and you can see there's some kind of layers. So for each points that's kind of layered like this, we have actually like 10 or 9 different levels. And for each level, we can simply assign an ASCII code for it. Now we're gonna switch to animation nodes. So animation nodes basically get the mesh data from Sverchok, which actually looking something like this. It has a position in X, Y, and also position in Z, and the Z represents the level of ASCII. So in order to turn this image into ASCII, I'm using this 9 character. This is actually, I'm following, there's like a GitHub article. Actually, there's a blog article. Just if you want to convert an image into ASCII, these 9 characters can represent from color white or something that's a bit darker, which is like this symbol right here. Let me increase the size a little bit. So these 9 characters can represent the ASCII to replace the grayscale value of this image. So this is what I'm doing inside animation nodes. So based on this mesh representations of this image, I'm bringing it into animation nodes, and the XY is pretty much as it is. But the Z, you see the Z value? The Z value will actually get these characters, and it's gonna kind of instance the characters for each point depending on the level in the Z. So that's what I'm doing here. Here, get list element, and then the indices actually comes from the Z value, which is the value between 0 and 9 or 0 and 10. And I just pipe everything in, and this is the result I'm getting. So this is one example. I could try it on different image. Perhaps let me try. I think we can use this image. So this image, this is a new one. I just call it mask 2, and then I'm gonna switch to Sverchok, and we're gonna try to perform the conversion using this setup. So I'm gonna unload the original image and get the second image. Gonna skip pixel, leave it on for now. You can go lower. Gonna load it and update the whole setup, and hopefully if everything works correctly, we're gonna get results. So there you go, that's the result. And let's try going lower with the pixel, which means we're gonna get like higher resolution. So it's taking a bit longer, but I think it's pretty much done already, I think. So let me try unload and load it again and update it. Let's wait a few seconds. So the whole thing actually can be faster if you are using Python codes or using things like processing, but this is yeah, I think that's actually done, and we probably need to scale the text somehow. So inside animation nodes, we can go in and then just maybe resize the text a little bit, 0.07. Extrude, maybe less extrusion, but I kind of like that result as well. So that's not too bad. So if we are using, so it is possible to turn like animated sequence as well into ASCII if you like, but that might take a while if you are doing it this way. Still possible. So view, top view. There you go, that's the ASCII. So you don't need, of course, if you don't like the ASCII, you can always go to the 3D version, you know. Currently it's just like a circle, but it can be anything basically. Can be any shapes. So if we are doing this kind of thing like a pixel by pixel sampling, that's kind of the old school way. Still, I found it interesting because 64 by 64 pixel or even lower or higher, you can represent some kind of symbolic image. These days you have like a neural networks and machine learning kind of stuff. So the machine should be like clever enough, instead of looking at the pixel, they are looking more like for a lot of other things like classified shapes and stuff. That's kind of like a high end, like if a computer by today, I think a computer, if you look at the mask like this, they should figure out, okay, this mask is looking like a human face, and they should be able to tell this is a mask, and the mask has the color of red, gray, white, and the mask resembles some kind of Chinese opera kind of mask, and maybe the machine should be able to tell you what this mask is from, what year, and then etc. What's the history. That's kind of more clever way for computer to kind of analyze an image. In this case, it's more like a pixel, and this is the old school way. I still find pixel is very interesting, and this day you have like high resolution image. Smartphone can take over 10 megapixels. You know, like megapixel is a lot, and 1 million pixel is actually a lot. And with pixel art, actually normally you don't go like millions of pixel, even though you can. You kind of more like working on the smaller dimensions and things like that. Like this artwork, for example, is only made of 40,000, or actually only 2,867. I have this total number of circle here. So that's yeah, kind of interesting. I guess hopefully you find it useful. So yeah, that's pretty much how another look at pixel art, and then how you can turn like an artwork photograph and then reduce the resolutions and turn it into ASCII kind of art, 3D ASCII inside Blender. Yeah, so that's pretty much it for this live noding. Hopefully this is useful. Let me know, and I'll see you next time. Thank you. Bye.